Welcome back. So imagine the following scenario. I have a software system. I would like to have a software system. I am going to identify that as the main. The goal of that software is to create items, to create objects. In my example, those objects are going to be used these bulbs. I am going to have a system, and the system is creating these objects, the bulbs. It could be exactly the same scenario if you think about a software system for the university, and these objects are students. Every time that a student enrolls in the system, there is an object student. It could be exactly the same scenario if you think about Amazon buying something online. Every single one of these objects represents one item that is going to be delivered. So if I am talking about a system, and that system is going to be creating a particular object, a particular entity, something that you know now is that it's a very good idea to implement a factory. And when I mention the word factory, I am talking about the factory design pattern. And you remember, the factory design pattern have a class diagram, a blueprint, and source code that you need to add to the system. This name, this word, represent a lot of work that is already there that you can reuse for your software. I am going to create this object. I need a factory. Done. You know what? These objects, the balls, are going to be put in an envelope. I have two options. I can put this ball in a box, or I can put this ball in a bag. I am going to use this envelope picture, depending on something. For instance, for this scenario, we can think about, well, they are balls, let's use the size. So according with the size, I am going to select a particular way to decorate the element. And I am going to use this decorate to remember another design pattern that you can use. What is the idea? That I am talking about a factory, one pattern, and now I am introducing the idea of decoration, another pattern. But I am introducing the idea of decoration together with this, that hopefully remind you the idea of the chain of responsibilities, another pattern. It's like, okay, you have a software system. In your software, there is one element that is creating things, the factory, and then I get those elements, and I am going to pass those elements to a group of entities, a chain of responsibilities, these guys that I draw here. And basically what is going to happen is that one of them is going to put an envelope to the object. One of them is going to put a decoration. The decoration could be this box, and I am going to have basically my original object plus the box, or maybe something else. Or at the end, there could be the possibility of an error, right? We need always to consider that, well, according with some size, it's going to be a box. According with a different size, it's going to be an envelope. But what if the size is not this one, not this one? Well, the object is going to reach the last guy in the line. And that guy cannot do anything. There is no other option. So report an error, mistake, return the element to the factory, some kind of action. The important thing here, I have the factory, I have the chain of responsibilities. The chain of responsibilities is doing the decoration. Obviously, I have these elements, the ball, the box, and I am going to use an envelope. If I share with you this scenario, And let's add one extra. If I have this factory and all these things happening, there is always a good option to have someone supervising, someone observing, someone taking care of the process. In particular, one element, the only element that I would like to take care is this guy here. Why? Because that one is the one receiving the errors, the balls that do not have the correct size, if you want to think about it. So could it be possible to have some entity, and I am going to represent that with the eyes, that basically is checking what happened with this one, checking how many times that one received an error, that one received a ball and cannot do anything, the supervisor connected, observing the last guy in the chain of responsibilities. That is my problem. Now, at this point, I mentioned the patterns, I mentioned the idea. Can you figure out how many classes you need to put this in a piece of software to create a program that do what I described? How many classes, how many interfaces, what are going to be the connection between the classes, etc. Hopefully your answer is yes. Hopefully your answer is we have a pretty good idea. More than 50% of the things that I need to do are just described in my knowledge of patterns. Because what I am asking you to do is take the class diagrams of the different patterns and put them together. And that is your software. Pretty standard solution. Obviously, there is kind of an intersection between different patterns, because hopefully you notice that, okay, some classes are going to be in two patterns, because in one pattern, they are the product, the factory, but in another pattern, they are the item, the one that is going to be decorated, or in some pattern, they are just one handler, but in the other, they are the observer or the observable. Intersections. And those intersections are going to happen also in the source code, not only with the diagram. I would like to create the solution for this, both the class diagram and the source code, because it's practically the same idea or a similar process that the one that you're going to follow with your assignment. Let's see. Step number one. This is kind of your talk with the customer. This is kind of the customer telling you what I need as a customer, the idea, the description of what is going to happen in the software, what I would like to have. Step number one for you, the engineers, is figuring out the classes, the class diagram. I am going to show you a middle point between a class diagram and something that is still use cartoons. This is not a class diagram, but my first step. Okay, forget about the cartoons, and now let's just use these rectangles. The rectangles to figure out what are going to be my classes and my interfaces and what is going to be connected with what. I am not using any UML symbol here. The lines are just lines, nothing special, no meaning there yet. You are going to help me with the UML. For the connections, could you agree with me that I am going to need a class main? That class main is going to be connected with a class that is going to have a name related with factory, the class that is going to represent the factory. Something that I didn't have here, but I am sure that you are going to add, and this is UML. This factory needs an interface. Remember the pattern? Every single factory is a child that inherits from an interface that represents, right? The abstract factory, that's correct. Now, if we have factories, we have products. If we have products, we're going to have an interface for the products. It is not mandatory in the pattern that the class have the name of factory or the product have the name of product. In this particular scenario, well, I am using factory because I do not have any other name yet. However, for the products, I am sure that you notice that I talk about balls. That is the product that I am creating in the factory. So that one is going to be my product. That one is the one that in the class diagram of the factory pattern is product. But it is better to call it ball because that is my particular context. What I am working is this idea of balls. That is the product. In a different scenario, that one could be student, or that one could be professor, or that one could be a quiz or an exam, whatever you are creating. That is the product for the system, right? It doesn't matter that you are talking about something in paper, a person, or an object is used for the computer. That is the product. That is what I am creating. So in this case, the balls. For the product, you also have an interface. You can imagine that this connection that I have here between product and the parent of product, this guy is going to be an interface. Just like with the factory, we need the parent, we need the child. The parent could be abstract product, just following the template. Here, something that I describe is, you know what? What I am doing is gifts. One gift, the first idea that I have about gift is these balls, but I can continue with another thing, cars, dolls, whatever. If you think about it, it's the same process. I can have a car or a doll, whatever, and what I want to do with them is the same thing that I do with the ball. Put them in a box or in a bag, the envelope. Same process. I am working with one child, the ball. I can add more. All of them inherit from the class gift. Anyway, the factory with the product. Now, in this point, we discussed before that we need decoration. And we talk about this product to be the original one. And to that original one, we want to add a box or an envelope. And in that moment, you think about, well, the decorator pattern. In the decorator pattern, if you remember the diagram includes two childs, a common parent, and as many decorators as you want to create. The elements that I highlight with green, those elements are going to be classes in the decorator pattern. Did you notice there are two classes in red that are part of the factory pattern, and they are going to be part of the decorator also. This common parent for product can also be the common parent for the decorator and the items. Moreover, this ball is a product, but also can be the item that we have in the decorator pattern. We need this decoration, a class that is going to be the common parent for the decorations that we're going to have. That one is new. It's something that I didn't have in the cartoons before. And the only reason because that one is going to exist is because I need a parent for these two, the box and the envelope. At this point, you remember the connections, hopefully. This is going to be inheritance. This is going to be inheritance. There is going to be this inheritance that already exists before, this inheritance that I need to create here. Moreover, a diamond here, with a connection here. And if you want to complete the previous one, for sure, association, probably association also, and we're moving forward. And the factory is going to be creating GIFs if you want, or up to you. Balls. Depending how do you handle this, both options are okay. The original one, the one that we described with the patterns, probably the longest one. The factory with the product, the concrete ones. And dependency. Remember the line that is with dash, not solid, is because the only thing that is going to happen in the factory is I am going to create the object, but I am not going to use the object. So use the dash. Yeah, the GIF is going to behave as the component. That is correct. And we're going to have a component decorator for the box and the envelope. Yes. So did you notice what is happening? We are solving the problem. We are using patterns, and those patterns are getting connected. Right now, these two. Now, moving forward. We talk about chain of responsibilities. Chain of responsibilities, you remember that you're going to have something similar to what we have with the decorator. In particular, we need a class that is going to put the box and the ball together. Probably another class that is the one that is going to call the ball with the envelope. And another one that is going to do nothing. The last one in the line. If you think about how to achieve that, what is the structure for that? I am sure that you're going to remember that something that we need to do is a common parent for these classes in blue. It is getting kind of traditional, common practice, that when we have a group of classes that somehow work together, we put a common parent. Yeah, that is what we do. That is object-oriented programming. That is the step number one for polymorphic behaviors. So a common parent. If you remember, this one is going to be what we call it handler with the patterns. And this one, for instance, is going to be the common parent of all of these guys. Yeah, I know that you're thinking like, well, in the pattern, we only have 2 childs. I am adding 3. The pattern is a template. The template is something that you can customize. Let's work with 2. If you work with 2, you remember that the key idea with the pattern is one of the elements is just a child with nothing extra. That is going to be the last one in the line. The other is the important one, like probably this one. And this one is going to have something extra. And that is the extra, the diamond. That is the connection for that part. Finally, if you think about the observer, I want this supervisor. And I want that one connected with this one. Oops, that one, the wrapper tree, is going to be part of the chain of responsibility, part of the blue part, but it's also going to be part of the orange part, the observer. For that one, very easy. We will need the class for observable subject. there is going to be some inheritance there, remember? And we're going to have this one as an observer. There is going to be some inheritance there. And these two are going to be connected, association, and done. That orange part is the observer observable. Yep. Generalization for the blue ones. Yeah, that is the correct definition. Adding a parent in terms of engineering, programming, the word is we are doing generalization. Yes. So I showed you in the slide the classes represented with these boxes. And what we do together is adding the relationships for a UML class diagram. Hopefully with this picture, what you have on the screen right now, you can figure out the class diagram for the solution. Step 2, if we have the class diagram, we understand the problem. Moreover, we understand the problem and we have source code equivalent for each of these patterns that basically the only thing that we need to do is to put that source code in our compilers and we will have the software. Let's check. Source code. I want to show you the solution in the source code because I need to be sure that you agree, that we understand why every single line of code is there. So I am going to try to show you the source code and I am going to try to relate the source code with a particular color, with a particular icon. So for instance, the blue one with the small factory icon, that source code corresponds to the factory pattern and so on. You're going to notice how the source code for the different patterns is going to mix in specific points in your code. Two options. Option number 1, you are doing a software like the one that we described, and you are going to start doing the programming, and we can start at the top and go down to the details. The top is the main. We can start with the main class, with the main method, and then complete the details. That is one option. The other option, the opposite. We can start with the details, creating all the elements of the classes, and at the end, create the main. Usually in my examples, I follow this approach. I give you the elements, and at the end, I show you the main. For this example in particular, I am going to do the opposite. I am going to start with the top, the main, and then show you every single element. So top, down, here. Number 1, the main. For the main, what we need to do in the main is to create the elements, that we're going to use. Element number 1, we need to create a factory. In order to create a factory, that is the instruction. And hopefully there is nothing that I need to explain in particular there. Important things to do. The type of the variable is the abstract class. The type of the variable is the class that represents the interface. Equal, new, the element, the class that we have. In this scenario, we are creating as an object an abstract factory, and we're giving a value, and the value is going to be an object from the factory of balls. The advantage of this, you know it, polymorphic behavior. If in any moment I want to change my factory and instead of doing balls, doing students, cars, dolls, professors, people, the only thing that I need to do is to change this. Everything else works in the same way. Okay, factory, done. 2, according with the description that I give you, the factory is going to be working. We need to do that later. But the other thing that is going to be working is the chain of responsibilities. The other thing that is going to be working is, this is the main, there is a factory, that factory is providing me with the product, in this case with the balls are coming, and here, what I am going to do is to send those balls to a chain of responsibility, to a group of people that are going to take those balls and do something with them. What I need to do is to create that. 1, 2, 3. Remember the 3 guys that I put in the picture? 3 objects, 3 handlers, 3 concrete handlers, because the parent is the abstract one. I create 3. Remember the name of the classes. I am creating one handler that is going to work with boxes, another one that is going to work with envelopes, and another one that is going to be kind of the last one in the line, the tail. 3 objects, 1 for each responsibility. For this one, something that I need to do is to connect them together. You have 3 guys, and you need the first one connected with the second one connected with the last one. This. The one with the box connected with the one with the envelope connected with the one of the tail. And this set method is the one that we reviewed before in the pattern. You can implement as many handlers as you want from any of the classes. Yes. We can have several options, childs, for the handler at the end. We can have several options for the handlers in the middle. Remember, the pattern, the only difference that it's going to ask you to do is the one at the end versus the others. The others mean from the beginning to one before the last one. Those are one class, the last one is another class. So 2 at least. In this example, I am showing you 3. So the last one, and here, the others are 2 categories, the box and the envelope. Blue, the factory. Orange, the chain of responsibility. The main is basically creating the elements. They are not working yet. Nothing is happening yet. The only thing right now is I have the factory, I have the guys that are going to be working. There are 3 guys there. Done. Next, I talk about this supervisor. I talk about this other entity that is going to be checking something. A new object from the class supervisor. But that one is going to be an observer. Those details are going to be in the class supervisor. Here, the only thing that I do is to create the instance. Done. I need to connect this one with the last element in the chain of responsibilities. This one, the supervisor, is going to be an observer and is going to be connected with the last one. Those 2 are connected. The factory, the chain, the observer. All the elements there in the diagram and in the source code. Next step, put things to work. I want to put this to work, and what is the first element that needs to start the scenario? Which is the first element that needs to do something? And hopefully you agree with me, the factory. Nothing is going to happen until the factory delivers the products. Okay, how many times do you want the factory to work? Here, I am sure that you can figure out several different things. We want the factory to be working forever. So could be a good idea to put the factory in a thread. For my example, I am going to do something very simple, a loop. So I am going to make the factory to work 5 times. It's not in the specification how many products do I want. For my example, 5 products. So I am going to wait for the factory. The factory is going to give me 5 balls. That's it. I can change that number, the 5, and make 100, 1000. Or again, I can create a thread and having the factory working forever, which could be better. But just for the example, a loop. Inside of the loop, that blue line, that is the line in which I request the factory a product. Do you remember? The factory is the object that I create here. Do you remember the method? Create. The name that you put here is the name that you use in the other class. You create this method because you follow the template. But here is the point in which you use the method. And this method is going to return to you the ball. However, in order to make this better, the variable is going to be GIF, the parent of ball. Any ball is a GIF. It is better to work with the variable GIF because that one can store any GIF. That can continue working if we change this factory here for dolls or cars. We still can store here a doll or a car or any other thing. Extensibility. But after the line 19, we have the product. The factory work one time. Next step, I am going to print on the screen something. I am going to print on the screen the GIF. Basically, what I am going to do is to call that method, and that method is going to print, hello, I am a ball, and maybe print the size or something. That is not part of any pattern. That is something that I am doing just for the computer to tell me that something is happening, right? The next line, the 21, is the line that corresponds to the chain of responsibilities. The line 21, if you remember, is the line that you put in the main in order to call the first handler, ask for something. And you can always send parameters. Hopefully you agree with me that makes sense, that if I have a ball and I want those guys in the chain of responsibilities to do something with the ball, I need to give them the ball. I need to pass the element, the item to them. And in programming, that is passing parameters. And the position to pass a parameter is that one. So you, handler, help me with this request. And by the way, you're going to need this GIF. The GIF is this ball that I get from the factory. Did you notice the connection? The factory is working, the element go to the guys that are going to do the decoration. And there are 3. And I am passing the parameter to the first one. But they are organized and they are going to work in this product line, right? We know that. That is the only thing that is going to happen in this loop. 5 times. 5 products from the factory, 5 times requesting help from the handlers. At the end, something that I am going to do in my main, this line in green, the supervisor is observing. That is happening in the background. At the end of the program, when this method finishes, I am going to ask the supervisor, please give me a report. Tell me, you were the supervisor, you were observing the guys that are doing the decoration thing. Tell me how many errors, how many times an element from the factory was wrong, and therefore we were not able to do the enveloping thing, the decoration thing. The last thing in the main. Hopefully you agree with me that this is the source code that describes the scenario that before I shared with you using the cartoons. The description of the problem, but now with source code. Software. This is going to run in your computer. Clear. Questions so far? Good. So next, the details. The details with the patterns. Number 1, the first one that we're going to ask to do something is the factory. So let's review the factory. Source code for the factory. You remember the diagram? You remember that we need the two parents, the two childs, and the connection between the childs. This is the source code. The abstract factory, the factory for the balls. Anything here, unclear, anything there in the factories that we need to review. And hopefully you read this and it's like, yeah, the abstract factory, the only thing that we need in the abstract factory is the definition of a method without a body. That method should create something. Therefore, the return is going to be the return of something. In this case, gifts. The concrete one should do an implementation of the interface. This one is an interface, therefore implements the same method, but with the body. With the body and the key element, this new. The factory, done. The product, we already agree on this. The product is going to be gift. I can define general attributes and general methods for gifts. For instance, I am talking about this size. That is something that I am going to use with the balls. But I can think that any gift is going to have some size. If I think about cars or dolls or whatever, somehow there is going to be a size involved, at least for my example. So I can put the variable here. I can put the variable in the interface if everyone else is going to use it. If I am going to have a variable size, then I will need a setter and a getter. That setter and that getter is because what you know about object-oriented programming. Attributes, private, and you need setters and getters to have access to them. The last one, I am going to have this print method. In the interface, it's going to be empty, but it could be a good idea that each of the childs, the classes that are going to inherit from gift, could be able to introduce themselves, could be able to print what they are or what is their size, right? So I am going to use that print method for that. For the interface, empty. In the childs, I am going to override those methods. In particular, this class ball is going to be a child, is going to extend gift. So these two are connected. And as you can notice, no variables here, but this one is going to have size. My constructor and the override for print. The constructor, nothing special there. Use receiving the size, using the method to set the size and print something. The print, use a message. Hello, I am a ball, my size is, this is my method working. Just for you to know that something is happening. Done. This is the factory pattern. You have 4 classes. You can move forward. Next. The chain of responsibilities. And this is a little bit more tricky. Chain of responsibilities. It could be important for you to remember the class diagram. It could be important to remember, hopefully you have it with you, the number one thing that you need, the first thing that you do is the common parent. The common parent, handler. For handler, a method that is going to be in all the other classes. The common parent and all the childs down are going to have an implementation of that method. That method, operation, handling request, whatever, is the one that we call from the main. Moreover, something that we're going to modify in the original pattern is, for us, we're going to use this parameter. our chain of responsibilities is going to be a chain of responsibilities handling requests with gift as a parameter. That's it. Everything here is from the pattern except these parameters. That is something that we personalize, something that we customize in the original definition of the pattern. Done, the common parent. Next, we need a child. A child that is the last one in the line, remember? That is one of them. Is going to be this guy, the one in the tail. I am adding that tail in the name just for you to remember what we are doing here. That is the last one. And the last one is a child that is inheriting from handler. Oops, we have a small problem here. Do you remember when we talk about the solution? Something that I need is for this guy, the one in the tail, to inherit from the handler. But also remember that this one is going to be observable because there is going to be a supervisor observing this guy. And in order to make this one observable, the solution is also related with inheritance. So basically what I am asking is that one, the one in the tail, need to inherit from the common parent for handlers because it's part of the chain of responsibility, but also need to inherit from observable because my goal is to observe that thing. Two inheritance. We are in Java. We can only do one parent, inherit from one class. However, we can use interfaces. We can use implements from several classes. What we are going to have is, well, one of those can be extend, but the other should be implements. Observable, I am going to use observable from the Java API. In the Java API, observable is a class. Therefore, I need to use extends there. Extends observable. Good news, I am going to use the library. I do not need to create the observable class. Bad news, because that one is using extend, now I need to use implement for handler, which is fine because this one is already an interface. Therefore, I can use implement with handler. One class, this one, the handler at the tail, that is at the same time a handler and observable. Two patterns in one class. Okay, now what I need to do? Well, what I need to do for the chain of responsibility pattern is provide some methods. Methods, the important one, this one. This one is part of the pattern. The constructor is just object-oriented programming. The constructor is something that you put in every single class. Nothing special for the constructor, nothing special here. The special thing for the chain of responsibilities is the method handle request, the override of that method. That is special for one of the patterns. What should I do inside? Whatever you want. The thing that I am doing is printing a message. I am printing a message. I am the last one in the line. This GIF have a wrong size, just because according to my problem, remember, the correct sizes are handled by the box and the envelope. So this is the last one. This cannot do anything. It's just going to print a message. Next, what should I do here? Because this one is observable. Do you remember in the observer pattern, what is the responsibility of those things that we define as observables? Do you remember the source code that you need to add? And hopefully, yes. And hopefully you identify that source code. There. Something that I want you to notice. I need the method handle request because one pattern. I need to add this set change and notify observer because another pattern. And just because those lines are together in one class, this guy, the concrete handler tail, is the last element in the chain of responsibilities, and also that one is observable. And if you ask about, okay, who is going to be notified here? It's going to be supervisor. You know that because of the main that we create. However, if you are the programmers doing this class, the answer is, you don't care. I am notifying my observers. Who are my observers? Which other classes are observing what I do? That is a different story. That is something that is defined in a different place. In this case, in the main. The only thing that you do here, notify them. Done. So almost done with the chain of responsibilities. The other thing that we need to do, this one, the child that is special, the child that is connected with inheritance, but also with this diamond, with the aggregation relationship. Number one, implement. Another one, implement. There, I have the relationship of inheritance, right? Not one, but two. I am creating two childs with that relationship. Moreover, this line here and this line here. Do we remember that this line 3 in both classes is the diamond? Those two are two examples, two cases of this part of the pattern, the special class. The class that is a child, inheritance, implements, but also have a local attribute, a variable from the type handler. And what is going to happen inside? Well, you remember that number one, constructors. Number two, the method that is going to do the handling of the request. The method that is going to do the handling of the request. Mandatory, according with the pattern, the element that we're going to search there, the element that is going to tell me that this is the special child from the handler class, this if condition inside. Do you remember? All the elements in the chain, all of them take a decision. The decision is, okay, this is a new ball. The size is the one that I handle. The size of this is the one that I need to put inside of a box, yes or no? If yes, I put this in the box. If not, I pass the element to the next guy. And the next guy is going to do the same. Okay, this size is the one that I put in an envelope, yes or no? If yes, I am going to work, put in the envelope. If not, I am going to pass to the next one. That is the programming that you have. Every single element, every single handler, the guys that I put in the chain, they are going to take that decision. This, if, else. Should I work or not? If not, did you notice those two methods? Those are exactly the same that we put in the main. Those are exactly the same that start the process. From the main, you send the request to the first guy. And that one, this one, the one with the boxes, is executing this condition And that condition is, do I work or execute this? And executing this is exactly the same thing that was executed in the main. And this one is going to do the same. Do I work or pass the request to other? And the last one, well, the last one we already checked, this one. This one cannot decide. There is no one else to put the request. This one is just going to report the error, whatever. Good. This part, the working part. What I am asking you to do is, this guy is going to put the ball inside of a box. This guy is going to put the ball inside of the envelope. It doesn't matter. The thing that I am asking you to do is to decorate one element. I am using this ball and envelope and boxes just as a cartoonish example, but is you have an object, decorate that object with another object. And you already know how to do that. Hopefully you remember this method add. Remember, like when you add a panel or when you add a widget, and the only thing that you need to do is to create the element that you're going to use to decorate. The ball, you receive the ball as a parameter. Inside of the source code, you create a new box or you create a new envelope, depending on the class. And you use the method add to put these two together. Together the ball and the box, first example. Together the box and the envelope, second example. Done. It is the description of the chain of responsibilities pattern. It is just that. With this extra for the observer, that's it. Next. Any questions so far? Good? Perfect. Okay, the decoration. We are going top down. So the factory, check. The chain of responsibilities, check. Now, something that is happening in the chain of responsibilities is the decoration process. Very important, guys. The decoration is not happening in the main. The decoration is happening in other class, and that is fine. The decoration can happen in any place. Any action in the patterns can happen in any place. The examples that we reviewed before, we usually use a main, just for the example. But when you put things together, well, there are going to be things in the main, but other things can happen almost in any place. You can connect things as you need to connect them. The first thing that you need to do is to figure out which are going to be those points in which the connection is going to happen, just like we did at the beginning. So for the decoration, well, we already have this. The GIF and the ball, we use those two for the factory. So already we have these two classes, at least with these elements, because of the factory. But you know that for the decoration, we need more. We need those three. And these two and these three are part of the decorator pattern, the things that the decorator asks you to do. Let's see. GIF and the product ball, done. We need the decorator. Remember the other class that is going to be the box. We need the decorator that is going to be the envelope. And this common parent is a brother, is at the same level that the GIF that we had before. Hopefully by reading the line number 1 in each of these pictures, the line number 1 here in these 3 plus the line number 1 in these 2 is telling you that We have a parent. That parent is having 2 children. And this one have this diamond, just like before. And this one have 2 children. This is what I have. The source code of the 5 things that I am showing you, this and this, is the diagram, right? And hopefully you can help me with the names of the boxes. Which is the box, the name for this one, the one at the top? Which is that one at the top? Maybe ball or gift or envelope or box. If I just ask you in the exam to put the names to the boxes in the picture according with the source code, that should be very simple, right? Gift at the top, decorator here. So far, I have only ball here, and the box and the envelope. I am using only the initial letter. I am assuming that this is okay for you, that you have the experience to know what I am talking about, the connections in the picture according with this line number 1. Following the pattern. Following the pattern, you know that the most important class here, the only one that could create some kind of problem in the programming, is this one. Everything else is simple. That one, the new class, the decorator class, is the special one, the difficult one. Is the one that have the inheritance, is the one that is going to have the diamond. This line there is the diamond. That one is the one that is going to need this add method in order to connect a value to the diamond. Moreover, is the one that is going to have the method with a particular source code that we need to include. What is that particular source code? Call the method using as an object the one that we have as a variable. That is the tricky part. That is the part that you need to remember. The decorator class, just working. For the others, constructors, nothing special, and overriding the method. Overriding the method, and the only thing to remember, always call the super. And after calling the super, do whatever you need to do according with the problem that you are solving. Nothing else. Right? Decorator, done. Questions? Okay, good. So factory, check. Chain of responsibilities, check. Decorator, check. Almost done. The observer one. We already put one of these guys, this one here, as observable. So we already implement half of the observer pattern, one of the parts. The second part for the observer pattern, the thing that I put in this green color, the eyes that I use in the example, we're going to use the classes from the library. Therefore, we need these imports. You need the same imports in the other class. I didn't add the imports because I assumed that your developer environment is going to help you with that. But well, you will need the imports. The supervisor implements the observer. The supervisor is going to be an observer. We define that from the cartoons. And the meaning for that, the things that I need to do here, beside this line, is to provide this method, to put an override for the method update. That method is defined here. I cannot change the name. I need to use that name. And I am going to receive information as a parameter. For my particular problem, the problem that I described to you, the only thing that the supervisor is doing, the only thing that is happening in the scenario is supervisor is observing every single time that one ball is delivered to the last element in the chain of responsibilities. And the only thing that the supervisor is going to do is to increase a counter. Nothing fancy. The only thing that I am doing is how many times that guy receive a ball, 1, 2, 3, etc. I am counting because I know that every time that a ball reach that guy, an error happened because the other two cannot use the boxes or the envelopes. Using my scenario, nothing special. So a counter. The last thing from the main, I call a method report. This is the method. Remember, the last thing that I did in the main, ask the supervisor to give me a report, to print a report. And that report is use this string. And the only important thing is printing the value in that variable. What is going to be the value in the variable? You start in 0, and every time that you do this plus plus, you increase in 1. So here it's going to be printing the total of errors, the total of problems. Done. That is the solution to my problem. We go from pictures, cartoons, my explanation of the situation, to a class diagram that hopefully you can complete because I just draw on the screen, to the source code in less than an hour, hopefully. 1 hour, some minutes. That is the process that you could follow for your assignment. Important things here. The patterns can overlap. That is fine. That is what is going to happen. The overlapping of the patterns is going to be something that you're going to notice in the class diagram. These classes that I put in different colors because the class participate in several different roles is also something that you are going to notice in your source code. If you try to put different colors to the source code that correspond to the different patterns, you're going to have something like this thing that I am showing you. In one method, in one class, source code lines that come from you using the pattern 1, the pattern 2, in this case, the factory, the chain of responsibilities, the decoration. So the blue lines, the orange lines, the green lines, this combination, that is what your assignment is going to look like. And that is totally fine. Common error is try to separate and have one class with only one pattern there. You are not going to be able to do that because that is not what happened in the real life. Software is a combination of patterns, just like this. Any question, guys? Clear. Next step. Everything that I described so far is without graphical user interfaces. If you notice, I describe a problem and the only thing that I am doing is printing messages in the console. That's it. You run your project, the project is going to run this loop, and in the loop, some things are going to be printed on the screen. That's it. So, question for you. What should I do if I want a graphical user interface for my system? This is what I want. What if I would like to have everything that I described to you, and I am using not the classes or the source code, but my cartoons. What if I want to have that? We already programmed that. But you know what? I would like to have this graphical user interface. And in my graphical user interface, well, I would like to have some menu items or buttons. And I would like to ask, for instance, this produce, click. And when I click produce, I would like to have the factory working. So instead of having this loop that I created before, the factory is going to produce something new when I, the user, click that option. You can think about this factory of students, but there is an option in the menu, and that option is enroll. So a new object, the student, is created when a human being click enroll. Someone is enrolling in the university or in the class, whatever. So that is the one. I have this observer that is reporting, but just at the end. Remember the main that I showed you? At the end, I show the report. What if I would like to have an option, and every time that I click there in observer, it's like asking the supervisor, can you tell me how many errors so far? Observer. When I click there, the supervisor provides me a report. And finally, well, I can have more things. I need to talk about this later. But these two, the factory working when I click here, the supervisor working when I click here, and instead of the console, I have this space in my program, a text area, in which we're going to print the messages. So everything is enclosed in this graphical user interface. If I ask you to add the classes and the programming to transform the source code that I give you, that is totally text-based, to something like this, can you figure out what to do? How many new classes do you need? What changes to do to the classes that I already showed you? Any idea? Very good idea here. It's like, are you asking about observing when the user click here and click here, and when that happens, we trigger the actions? Yes, I am talking about that. Yes, it's about observing. Do you remember the name for the observers of the widgets in the graphical user interfaces? In particular, yeah, the action listeners. I am going to describe the solution, use talking with you. Hopefully, what I am going to say makes sense and remember you a particular class diagram, moreover, a particular source code. Number one, the main class should extend JFrame. Second, should implement action listener. Those two things are going to happen in the line one of the main. Second, you need to have an action perform method. Inside of the action perform, you need to put this line, move that line to the action perform, move these lines to the action perform. You remove these blocks from the 19 to the 21 and the 26 from the main, no longer in the main, and you send those lines to your method action perform. In particular, there is going to be an if else there. You need to identify which option in the menu the user click, and for one of them, the option A, for the other, the option B. And all my system out print something should become access to the text area, access to that place, right? Now, one last thing. If you're going to have this text area, and the text area is going to be used in several different places. And obviously, it's only one text area. So just an idea, my recommendation, try to run the source code. As a practice, could help you for the assignment. Any question, let us know. Next week, I will move forward to the architectural patterns. Any question? Okay, so I will stop here. Thank you. See you next week.